Okay. You got them? Make sure you pay attention. I'm gonna graph this. My window's probably off because I was doing other things with grade 11 the other. Oh, perfect. Didn't even have to change a thing. Interesting. So this is my window. This is going back to yesterday's the Ferris wheel question. And so let's go and continue what we didn't finish on page 20. Just a reminder, what does this say here? We're comparing height and time and minutes, okay? And always read, like before you answer any other questions that follow a graph or just in general, please read every little piece of the question. The ride goes on for 5 revolutions. Okay, let's make note of that as we go on to 20. Page 20. How long does Tom stay at or above 30 feet during 1 revolution? How would you do this one? So you have your wave like this. Just keeps going. 45 is the tallest, the highest this ride ever gets to. So 30 is approximately here. Okay, this is your 30 feet mark. And you're like, there's many, right? There's many times. You just have to focus on one cycle. So I'm just going to focus on one peak because the time you spend at 30 from here to here is going to be the same as it is from here to here. So every little hill is going to be the same. So focus on one. Grab your calculator. Let's get rid of all those lines in the meantime. I'm going to get rid of whatever is in Y2, Y3, and Y4. And I'm just going to type in 30. And there it is. So second trace 5. Let's figure this one out. This is the first time on its way up. I'm going to go a little closer to that point. Enter, enter, enter. You want full marks? If you want full marks, turn this into 4 decimals for now because you're not answering the question just yet. And this is time 2. I'm going to go up here. That's going to be 2.63499. So what does that round to? 5, right? 50. If you do 4 decimals. Conrad, I'm just wondering, did you get the same answer as me? Okay. I thought you were kind of looking at the question being like, that's not what I got. I just want to make sure. Okay. All right. How long? So it's delta time. It's time 2 minus time 1 on its way down and it's on its way up. So we're just going to go 2.6350 minus 0.9567 and we get I have something completely different on my key. That's a different question altogether. 1.68. And we are what? What are our units when we're dealing with time? I think it's minutes. Yeah, we're minutes. So there we go. What if it says time below? Time below 1.68. This is above, so I'm going to say this is above. At or above. If it said below, this is just a note here. Time below, just take one cycle and subtract time above from it. Right? Because what one cycle is what? How many minutes for us? Do you remember? One period is one cycle, 4 minutes, minus the time we spent above 30. And that'd be 2.32. This is just a note, an aside. It didn't ask for it. We just wanted the 1.68, but I'm preparing you for an event that we don't know is going to happen, right? So whenever you subtract, you're going to find what's happening in between those 2 points you found. Well, we're spending time above it, right? If you were to draw a line down here and you find the intersections and you subtracted that, what would you find? The time below, right? So the cap is, you got to think of what are you subtracting. State the domain and range. Let's do one at a time. The range is the easiest one. Let's do that one first. What are the two numbers that I'm hovering in between? What's the lowest height I ever get to? 5, that's my min. And what's the highest? 45, that's it. Right? If you need to do interval, it would be, if H is the letter they use, you would use this method. Okay? For domain, it's going to be a little different. The ride starts at 0 times 0. And how long does it go for? 5 revolutions, right? So not 4 minutes, right? That'd be one revolution. So 5 revs times 4 minutes. So that's 20 minutes total. So that is what you put in here. In this case, it's finite, it stops. In 20 minutes, we're done. You get off the ride, you get to pay again. Okay? That's kind of what's happening here. And this gets me to, I was looking through the notes again, and remember when I asked you, I said to scratch the what does this represent, the y-intercept? Let's go back to 19. I just want to explain that though. What I needed you to know at the very least, in 19, question D here, what does it represent? It is the initial height, right? Don't forget that. The initial height at time 0 minutes. Okay, so that at the very least I would expect you to know that. Why is it not 5 feet? That one was going too far, in my opinion. It didn't make sense. There was not enough context for that. Okay, so this concludes this word problem, but let's focus on this part here. See if you understand your sinusoidal. Let's write this down one more time here. That is a sinusoidal. And every letter, A, B, C, D, does something to it. It affects it, right? What would this letter affect? How would this affect your sinusoidal? If you made it larger, it would be, right, it would move further away from the from the median, right? If you made this larger, you would actually shift the whole thing up and down. Okay. What would happen if you change this? It would affect your period. Okay. This would actually affect the max and the min. This would also affect the max and the min, as well as the median. It would shift the whole thing up and down. Okay. So if this question asked you a Ferris wheel that is higher off the ground, right? Write an equation that would model a Ferris wheel that is higher off the ground. I'm going to say this. I'm just going to copy. They have HT, H of t. You got to stick with that. H of t, 20 sine, and we're just going to do the 1.57075 t minus 1.25. I'm just going to change this to, I'm going to use a red pen for that part, plus 30, okay? Plus 30 plus 26, anything is going to take this higher, right? So if you imagine your wave like this, the plus 30 is going to make the whole thing be higher off the ground. Ferris wheel that takes less time to complete a full revolution. Less time. What does that mean? A shorter period. Now the question is, what do I do? Do I increase B or do I decrease B? If you increase it, so you got to think it's a period is 2 pi over B. The bigger you make this number, the smaller your answer is going to be, correct? The bigger B becomes, the smaller the period, right? So increase this one right here. That's all you have to show. So I'm going to keep everything else the same. Aaron, are you actually following, or are you just, okay. Plus 25. I'm going to keep everything else the same. And I told you I was going to change B, so sorry about that, I didn't. But I'm essentially going to use the same number. I'm just going to change something on it. I'm just going to go 2.57075, because it doesn't matter. It probably will be a lot faster now, right? So maybe uncomfortably faster for whoever is. I don't like Ferris wheels, so the teeter-totter effect, I just do not like it. So this would be probably a lot faster, and so if you don't like Ferris wheels, you would not want to go on this one, okay? A Ferris wheel that would go 5 feet underground. I'm going to let you do this one. I'll let you figure it out. And then I also want you to try this last one. So these two, based on the question, and this one goes way to the beginning, okay? This one goes way to the original, use the original equation for this one. So try both of these. I'm going to make a note here, otherwise you're going to use, that's the one. That one pre-turn around now, okay? All right, you want 5 feet underground. So if you maybe writing out the equation as is, and I'm going to erase this, but for now let's just put it this way. You want your minimum to be what? -5, okay? If this is what you want, we want the minimum, okay, to be -5. How do you get your minimum? We go midline minus A, correct? So what would we have to change this to make that happen? 25 minus what? 30, right? Because if you go 25 minus 30, you're at -5. So I'm going to change this to 30. Check. Okay? Minimum is 25 minus 30, which is -5. And where you go, now you have a Ferris wheel that makes that happen. Would there have been a different method of doing this? Has anybody tried something else? Because there are other ways. Anybody? You could have brought this down to 15 and left this at 20. Because if this is 15, what is 15 minus 20? It's also negative 5. So however you're able to figure that out to make this happen, that is fine, okay? Or, if you don't mind writing this down, 20, actually you would be fine leaving everything else like this. I'm just gonna go T, and I'm gonna close that bracket, and I'm just gonna go plus 15. Because it doesn't have to be the exact same equation as long as you make sure that this has a minus 5 minimum. So minimum would be 15 minus 20, which is negative 5, check, right? So you can, I'll put it this way, okay? When it comes to the height, you can play with either A or D, whichever one you find easier, whichever one you can, when it comes to the period, which is the only one that you can change, the value of B, right? You don't have a choice there. You need to make sure you change that one. What about this one? How many times will Tom have reached the highest point in the first 5 minutes of the ride? I will say this. There are ways of doing that. Let's graph it. You need to have a way to know where the 5-minute mark is. Okay, follow along with your calculators, or at least look up here. What I'm going to do is I'm going to go find it. Second trace 1. I'm going to go 5 minutes. I'm going to press 5 and then hit enter. And it shows me right there. That's where the 5-minute mark is, right? You see that blink, that dot there? So how many times? Just one time. It just happened one time. What if I had said after 10 minutes? 10 minutes is right here. It's just slightly over the peak. How many times would you have done it then? 1, 2, 3. You're technically over the peak just by a little bit. That's the best way I know how to do it, okay? When it asks you questions like that. So I'll just say this. Second trace value, x is equal to 5, and I'm just going to make this on my graph here. It was blinking right here. Okay, this is the 5. How high am I at 5? 531.30. That's the point I found. Okay, so it's just once. Okay, just once. Just one time. So if they ask you things like that, there's ways you can use technology to help you out. Okay, I'm going to pause here for a bit, and I'm going to ask you to try a few. So I'm going to ask you to go to page 23, I believe. Let me just check, because I made some changes. 23 and 24, let's try those for now. But it keeps going. I'm going to stop you. I'm going to say 26 for now. And then we're going to do regressions. Some of you were asking me, how do you do regressions? I forgot how to find the actual equation. I will show you how to do that after you do a little bit of work. But make sure, let's go to 21. Regression, so highlight that top part. Sinusoidal regressions. We have two types. Listen carefully, two types. Type A is very straightforward. You pray that that's the one that's going to be on the exam, because then you don't have to come up with the points. Okay? Enter them into your equation and answer as needed. Mr. Dirksen is going off-roading with his Jeep. He gets to a point on the road where there's 1 foot of water. 21. The height of a certain point on one of the tires with respect to the water surface has been recorded. Determine the sinusoidal equation. Please don't argue with the question. It's telling you it's a sinusoidal. You put this into L1, you put this into L2. Make a note here. How many points do you need? Did anybody remember? You need 5. Need 5 points. So if you don't have them, you're going to have to come up with 5 consecutive points. So let's type that into our calculator and get the equation from this. Okay, so go ahead and do that. You press clear at the top of the column to clear everything. This is a horizontal table. Make sure they match. Double check to see if you did this right, entered the right values. You got it? Then you press Stat, Calculate, and you have to go all the way almost to the end. You see sin reg there, sinusoidal regression. Select that one. Go second 1, comma, second 2, comma. Anybody remember the last step? Alpha, trace, enter. And just type that in. 2 decimals, okay? So all you need to do is sin reg, L1, L2, and just write it out. So it's 3.03 sine, and B is 3.1485. That one I usually write down 4 decimals, because if they ask for the period or I ask you for it, then it's better to have it in 4 decimals, and you don't get penalized for having more than 2 on an equation. You do get marked deductions if you have fewer than 2. 1 point, so plus 1.92. So that is the equation you're supposed to get there. Every single point that is now going to result will be time and height, because sometimes it can be distance. It can be distance. It can be, so just make sure you're consistent. And now you have your equation. Now I can ask you anything I want, right? Once you have the equation, it's just back to a word problem. Okay. That's it. That's all I'm going to do for now. I'll post the answer key. 23 to 26. I may have the answer key just appear once on the video so that we can